Welcome to the e-learning course concerning the familiarization of students with the offshore oil and gas industry. In the next 50 minutes we will take you to an educational tour concerning the offshore oil and gas industry. During this e-learning course, significant information for the concept of blue growth, the economic overview, the required academic qualifications, the necessary technical skills and behavioral competences, and the potential job opportunities for a successful professional career in the offshore oil and gas industry will be presented. Special focus will be given to the Eastern Mediterranean and Black Sea region. "71% of the Earth's surface is water. It is a very high percentage, and it is imperative the need to further harness the oceans, seas and coasts in order to create jobs and value, always from a sustainable point of view. This is the blue growth concept we have been hearing about. The blue economy represents roughly 5.4 million jobs and generates a gross added value of almost 500 billion euros a year, while the output of the global ocean economy is estimated at 1.3 trillion euros today, and this could be more than double by 2030. The European Commission has since reiterated that Europe should not miss this opportunity. Our coasts and seas have the potential to deliver growth and jobs in the years to come. Ensuring sustainable blue growth in marine and maritime sectors, we need highly qualified and skilled professionals. For these reasons, 4 marine and maritime economic activities have been selected as of strategic importance in the Eastern Mediterranean and Black Sea region. These include both traditional as well as emerging industries in the region, namely maritime transport, cruise tourism, marine aquaculture, and offshore oil and gas. Maritime transportation includes operating vessels, shipbuilding and ship repair. Cruise tourism industry consists of cruise lines, travel agents, key suppliers and cruise line partners including ports. Marine aquaculture refers to the culturing of species that live in the ocean. We consider marine aquaculture that takes place in the ocean, that is in cages, on the seafloor, or suspended in the water column. Finally, offshore oil and gas industry refers to the development of oil fields and natural gas deposits under the ocean. The majority of oil and gas production in Europe takes place offshore. As a result, the European-funded Project Mentor is focused on these 4 main sectors. Oil and natural gas form as the result of the decay of marine organisms on the ocean floor. Sediments, for example clay and mud, are deposited on top of the organic matter, creating anoxic conditions that prevent decomposition. As a result of the burial and compaction, the organic material becomes heated and hydrocarbons are formed. The hydrocarbons form oil and gas, which are forced out of the source rock and accumulate in porous rocks, for example sandstone. The formation of fossil fuels, coal, oil, and gas, takes place over millions of years, making them a non-renewable energy source. Globally, we consume 96 million barrels of oil every day. This is the same as 48 supertankers of oil every 24 hours. So, what is all that oil used for? Well, we as consumers, we use almost all of it. If you take a barrel of oil, 42% of it will be turned into gasoline for our vehicles, 28% will be turned into diesel, which runs our commercial fleet including trucks, trains and barges used in transporting goods, 12% is split between fuel oil, aviation oil, for heating and travel respectively, and the last 18% is used for asphalt, petrochemicals and plastics. Of the 96 million barrels of oil produced today, it's split about half and half between developed and developing nations. The growth in population and the increased urbanization will outpace the electric car and energy efficiency for oil consumption. and as a result the global demand for oil will likely go up by another 18 million barrels per day until about 2040, where it is expected to level out and start to decline. Natural gas plays a significant role in the global energy mix. It is the number 3 fuel after oil and coal, reflecting 23% of global primary energy, and it is the second energy source in power generation, representing a 22% share. It is anticipated that in 2040 the natural gas will be the second fuel in demand, and its share will be the 26% of the energy supply mix. Natural gas-rich regions like the Middle East and Russia-Caspian rely on natural gas to meet about half of their energy needs. Abundant unconventional resources prompt North America's steady shift toward natural gas. It plays also an important role in fueling economic growth in Asia, Africa and Latin America. As an abundant, versatile and cleaner-burning energy source, natural gas is increasingly a fuel of choice for homes, businesses and large-scale electricity generators. It supplies about a quarter of the energy for industry and electricity generation in 2040. Furthermore, residential and commercial users continue to rely on natural gas as a convenient, modern fuel for heating and cooking. Finally, natural gas is a small fraction of transportation demand, but sees strong growth in the commercial road and marine sectors. The term offshore means off the coast. In oil and gas extraction, offshore refers to the development of oil fields and natural gas deposits under the ocean. Oil rigs are used for the offshore exploration and production of crude oil. Crude oil deposits in the ocean that permit underwater drilling and extraction are developed and exploited using oil rigs. The drilling platforms used for development are subsequently replaced in part by production platforms. Offshore rigs are also used for the underwater exploration and production of natural gas. In order to develop and exploit natural gas deposits under the ocean, drilling platforms are erected and later in part replaced by production platforms. Offshore drilling began in 1897, just 38 years after Colonel Edwin Drake drilled the first well in 1859, and the first offshore platform was installed in 1947 near the coast of Louisiana in 6 meters depth of water. Shallow water is defined as water depths up to 305 meters. Deep water is defined as water depth from 305 meters up to 1,524 meters, and ultra-deep water is defined as water depths more than 1,524 meters. The Golden Triangle, Gulf of Mexico, Brazil, and West Africa, is home to primary deep water operations. In recent years, activity has also expanded to the North Sea. These 4 areas encompass 65% of the deepwater rigs worldwide. Offshore oil production has remained steady at around 26 to 27 million barrels per day over the last 10 years, whereas natural gas production, especially from deepwater drilling, has increased by almost 30% in the past decade to more than 1,000 billion cubic meters. An oil platform, offshore platform, or offshore drilling rig is a large structure with facilities for well drilling to explore, extract, store, process petroleum and natural gas which lies in rock formations beneath the seabed. The oil industry uses maritime drilling platforms or drilling rigs and production platforms that are classified according to their intended purpose and to the depth of the water in which they can function. The major types of offshore oil rigs include the following. A fixed platform is a type of offshore platform used for the production of oil or gas. These platforms are built on concrete and/or steel legs anchored directly onto the seabed. Fixed platforms are economically feasible for installation in water depths up to about 300 meters. A jackup rig is a barge fitted with long support legs that can be raised or lowered. The jackup is maneuvered self-propelled or by towing into location with its legs up and the hull floating on the water. Jackup rigs can only be placed in relatively shallow waters, generally less than 120 meters. In some special cases their operational capability may reach up to 190 meters. Compliant towers consist of slender, flexible towers and a pile foundation supporting a conventional deck for drilling and production operations. Compliant towers are designed to sustain significant lateral deflections and forces, and are typically used in water depth ranging from 370 to 900 meters. Semi-submersible platforms are floating units widely used both in the drilling and the production. Its structure can include one or more decks, which are supported by columns or legs on pontoons. They operate up to 3,000 meters water depths. Tension leg platforms are an evolution in the concept of semi-subs. The main conception behind its construction is the use of legs as a base, which are secured to the seabed with tethers tensioned in the platform and connected to the legs. These platforms are particularly suited for water depths greater than 300 meters and less than 1,500 meters. A drillship is a maritime vessel that has been fitted with drilling apparatus. It is most often used for exploratory drilling of new oil or gas wells in deep water but can also be used for scientific drilling. Early versions were built on a modified tanker hull, but purpose-built designs are used today. Most drillships are outfitted with a dynamic positioning system to maintain position over the well. They can drill in water depths up 3,650 meters. Gravity-based structures are huge concrete or steel structures that sit on the bottom and contain production storage tanks. The gravity-based structures are suited for water depths up to 200 meters. For drilling wells up to 3,000 meters, naval architects have designed a type of drilling and production platform which has a hollow cylindrical hull that can descend up to a sea depth of 200 meters. These are called spar platforms. This type of platform is secured to the ocean floor by a complex network of cables and tendons. Today, there are approximately 1,330 offshore oil rigs around the world. In Europe, the North Sea has the highest density of offshore oil extraction, with 184 rigs shared between the United Kingdom, Germany, Denmark and Norway. In the Americas, alongside the second-place Gulf of Mexico with 175 rigs, the waters around Mexico and Brazil have 88 and 51 rigs deployed, respectively. Far East and Southeast Asian fields take the fourth and fifth spots, with 155 and 152 rigs each. The Persian Gulf has the highest density of all, serving the Gulf states and Iran with 159 rigs. Currently there are more than 600 platforms, not counting the large number of subsea structures connected to them operating in the continental shelves of the European member states. In the North Sea, hydrocarbon offshore production takes place in the Danish, Dutch, German, Irish, Norwegian and UK sections. Offshore production is also taking place in the Mediterranean, mainly in the Italian continental shelf, but also in Greece, Spain and Croatia, in the Polish sector of the Baltic Sea, and in the Black Sea, mainly in the Romanian and Bulgarian continental shelves. Apart from explorations in the North Sea which are ongoing, increasing exploration plans are foreseen for the Mediterranean region in the Cypriot, Greek and Maltese continental shelves, the Black Sea in the Bulgarian and Romanian continental shelves, as well as for the Atlantic east coast in the Portuguese continental shelf. Oil and gas exploration or production also takes place in close vicinity of the EU, off the coasts of Algeria, Egypt, Israel, Libya, Tunisia, Turkey and Ukraine. In the context of the Mentor project, a total of 119 questionnaires have been collected and have been statistically elaborated. They represent 4 countries: Bulgaria, Cyprus, Greece, and Romania, and the aim of this analysis was to determine the required academic qualifications, technical skills, behavioral competencies, as well as the professions with the highest demand in the offshore oil and gas industry. The questions were divided into 2 sets. The first set of questions was referred to the current trends and needs within the industry, whereas the second one to their future analogs. Since the target group of this e-learning course is the students, the presented results are referred to the future identified gaps and trends of the offshore oil and gas industry. Academic qualifications are the degrees and diplomas that an individual has acquired, whether by full-time study, part-time study, or private study, whether conferred in the home country or abroad, and whether conferred by public or private educational authorities. As far as the necessary academic qualifications is concerned, all gathered data regarding tertiary education were collected and grouped based on its relevance. As a result, 11 main categories of tertiary education degrees identified in the questionnaires, namely, naval architecture and marine engineering, civil engineering, mechanical engineering, computer science, economic studies, chemical engineering, environmental engineering, geology, human resources, medical studies, general academic qualifications, and other specialization courses or lower-ranking crew. These academic qualifications can be classified based on the proposed taxonomy by the International Standard Classification of Education. The International Standard Classification of Education 2011 has 9 levels of education, from level 0 to level 8. Level 0 to 2 represent lower educational certificates, levels 3 and 4 refer to medium educational certificates, and levels 5 to 8 correspond to higher-level educational degrees and diplomas. The elaborated statistical analysis was performed on 2 different levels. The first level was based on the results of the whole region for the offshore oil and gas industry. The second level of the analysis, all the available information can be distinguished between the 4 countries of interest: Bulgaria, Cyprus, Greece, and Romania. An initial examination of the aggregated results of the region provides significant insight concerning the academic degrees with the highest demand. A degree in naval architecture and marine engineering or a degree as lower-ranking crew is located in the first place for the next decade with 18%. In the second spot can be found the degrees in mechanical engineering and chemical engineering, environmental engineering with 14%. A degree in civil engineering or in economics is located in the third place with 10%. Finally, a degree in computer science, geology, human resources, or medical studies will also be in high demand in the offshore oil and gas industry the next decade. Another significant aspect of the Mentor project concerns the pairing of the academic qualifications with the highest demand in the next decade in the offshore oil and gas industry. With the existing academic institutions in the Eastern Mediterranean and Black Sea region that provide the necessary educational courses for these qualifications, in this context some illustrative examples are presented subsequently. By studying at technical universities with schools or departments in naval architecture and marine engineering, a potential student can obtain the respective degree. The Technical University of Varna in Bulgaria, the National Technical University of Athens, and the University of Galati in Romania are some proposed institutions for this academic qualification. Similarly, the National and Kapodistrian University of Athens, and the Technical University of Crete in Greece, and the European University Cyprus provide courses in the field of computer science. The duration of the studies varies between 3 and 5 years. A degree in civil engineering consists of one of the highest in-demand academic qualification. The Frederick University of Cyprus, the University of Thessaly in Greece, and the University of Architecture, Civil Engineering, and Geodesy in Bulgaria are some indicative institutions of the region for this qualification. In addition, based on the elaborated statistical analysis, a degree in economics is characterized as the second highest in demand qualification. A student who focuses on this field has a variety of institutions to choose from, for example the University of Piraeus, and the Athens University of Economics and Business in Greece and the University of Nicosia in Cyprus. Finally, the University of Technology in Cyprus, the Petroleum Gas University of Ploiesti in Romania, and the University of Mining and Geology St. Ivan Rilski in Bulgaria provide academic specialized courses in offshore geology. The time duration of this degree lasts 3 to 4 years. Technical skills are the abilities and knowledge needed to perform specific tasks. They are practical, and often relate to mechanical, IT, mathematical, or scientific tasks. Some examples include knowledge of programming languages, mechanical equipment, or tools. While technical skills are often most important for jobs related to information technology and other fields in the sciences, many other industries also want employees with at least some technical skills. Many of them require training and experience to master. 23 technical skills were identified as necessary in the upcoming decade for the offshore oil and gas industry, namely, auditing management systems, big data analytics, communications, diving, drilling, electrical and control, electronics, energy management, first aid medical care, hardware computer IT, hydraulics pneumatics, languages, machinery damage and repair, management systems, occupational health and safety, operating systems, project management, risk assessment, safety survival firefighting, technical design, technical writing reporting, training other, and welding materials non-destructive evaluation. The statistical elaboration of the Eastern Mediterranean and Black Sea region show that the most crucial technical skill the next decade will be the project management with 32%. Technical design and drilling follow with 26%. In the third spot can be found the operating systems with 21%. Last but not least, big data analytics and technical writing and reporting are necessary with 16%. Whereas the remaining technical skills are located in the 5th and 6th place with 11% and 5% respectively. Competence is defined as a cluster of related abilities, commitments, knowledge, and skills that enable a person or an organization to act effectively in a job or situation. Because each level of responsibility has its own requirements, competence can occur in any period of a person's life or at any stage of his or her career. In the distributed questionnaire, a pre-selected list of behavioral competencies was included, and participants should indicate the top 3 required for the offshore oil and gas industry. The aforementioned competencies are leading, persuasive, deciding, planning and organizing, business awareness, analyzing problem solving, communication in writing, networking, teamwork collaboration, flexibility adaptability, resilience, personal motivation and adherence to principles and values. Life and work conditions on the board of offshore oil rigs are heavy and strict. The extreme isolation of so specific a place, the presence of such hostile surroundings as it is the open ocean and the cold or very hot weather leave nobody passionless. As a result, the behavioral competence of flexibility adaptability is the most essential with 47%. Planning organizing follows with 37%. In the third spot can be found the teamwork collaboration with 26%. In addition, leading and adherence to principles and values are required with 21%. Finally, the necessity of the remaining behavioral competencies varies between 5% and 16%. The offshore oil and gas exploration and production industry offers a wide range of occupations for both entry-level and experienced professionals. Offshore occupations can broadly be classified into four main categories that include exploration, design and construction, installation, and operations and management. In the context of the Mentor project, a wider profession categorization was implemented in order to analyze in depth the offshore professions with the highest demand in the next 10 years. Hence, 14 offshore profession categories were materialized, namely, high-level offshore personnel, medium-level offshore personnel, low-level offshore personnel, engineers, housekeeping personnel, logistic personnel, consultants, crane operators, onshore officers, lower-ranking deck crew, bridge officers, engine room officers, office personnel and manager. Some of the aforementioned categories represent more than one profession. For example, the naval architecture and marine engineers, the mechanical engineers, the civil engineers, and the chemical engineers are included in the category of engineers. The statistical elaboration of the collected data provided significant insight with respect to the professions with the highest demand in the offshore oil and gas industry. The profession of the naval architecture and marine engineer, mechanical engineer, civil engineer or chemical engineer is the most promising career selection for the next 10 years with 88%. The mid-level offshore personnel, for example driller, dynamic position officer, motormen, etc. are in the second place with 47%. The low-level offshore personnel, for example welder, roustabout, floorhand, etc., and the high-level offshore personnel, for example tool pusher, senior dynamic positioning officer, subsea supervisor, etc. are located in the third spot with 35%. The future demand of the other profession categories fluctuate between 6% and 24%. No matter where the oil rig is located, it operates 24 hours a day, 7 days a week, no matter what the weather is like. This means the hours are long and the conditions are sometimes very dangerous for the people who work on the rigs. Advances in oil drilling mean many of the tasks are automated, but there are still plenty of very physically demanding aspects of the job. Offshore crew normally works in 12-hour shifts. Usually, they work offshore for 14 days followed by a rest period onshore for the next 14 days. They are well trained in safety and environmental regulations to ensure the safety and protection of oil rigs and the people working there. Offshore occupations include different levels of emplacements in the fields of production, drilling, rigging, surveying, piping, welding, diving, quality checks, as well as in health and safety, cooking and support staffing. In the next 10 minutes we are going to get familiarized with some representative offshore professions. Roustabout is an entry-level worker, low-level offshore personnel who only meets very minimal job requirements and can be compared with a deck cadet on a ship. Basic school education as per local legislation is the only essential requirement. Many people selected as roustabouts have manual labor or technical experience, such as working as a mechanic or in construction. Roustabouts who work on an offshore rig may have the following assigned tasks and duties: rig platform cleaning and repair, machinery and equipment maintenance, and handling cargo delivered by ships and helicopters. This position comes with an average salary of about €32,000. The driller is responsible for supervising and carrying out the drilling and well control and other work in connection with the drilling operations. He or she must ensure a safe operation of the drilling control system, pipe handling systems, mud circulating systems, and blowout prevention equipment in accordance with the requirements specified in the operating procedures. This position comes with an average annual salary of about €50,000.
If you would have asked me 3.5 years ago what I would be doing, I would have never said oil and gas. I knew I wanted to do engineering. I love math, I love science. The ability to be in the field and to be hands-on was really important to me. Instead of going opposite directions, they'll be parallel.
Oh, really?
I've been with Shell for 3.5 years and I learned something new every day. I was given a rig within my first 3 months of working at Shell. Of course, I had my mentor there with me, and that really helped me feel comfortable in my work environment. I don't know many other professions or many other companies that would give somebody so early in their career so much responsibility. It helps you grow very quickly. Your learning curve just escalates like you would not imagine. I have Calmina working on those plans right now.
Yeah, Mr. Charles.
Hey Charles, what you doing? I never felt like I was alone because you have a global network. The calculator volume came back and we didn't see. So I know that somebody out there knows this issue that I'm dealing with, and I can pick up the phone and, figure out whatever I need to. One thing I love about Shell is the training that you get. Drilling engineers, geologists, petrophysicists, we all come together and learn about the business as a whole. Everything I do is a team decision. It requires me to reach out to other people to make that happen. The connectedness of the company, and we're all shooting toward a common goal, is just amazing. My name is Anna Flanoy, and I am a drilling engineer. When I tell people what I do, they don't believe me, but it's fun. I love it.
The crane operator is responsible for the daily operation and maintenance of the cranes, and in addition to this, manages the roustabouts. He or she supervises that all activities are carried out in accordance with the barge engineer or assistant barge engineer's instructions, and delivers essential on-the-job crew training within lifting and slinging. Furthermore, the crane operator functions as the helicopter landing officer in connection with helicopter operations. This position comes with an average annual salary of about €55,000.
My name is Chris Bynum. I'm a lead crane operator. They're nice cranes. They're really nice cranes. The nice thing about them is they're actually designed and built for the offshore industry on these rigs.
Chris Bynum is working on the ultra-deepwater drillship Maersk Viking in the Gulf of Mexico. The Maersk Viking is state-of-the-art within safety. For instance, this new concept for the cranes. They have been specially designed to keep the swing motion of the load to a minimum.
Anytime you can eliminate any of that, it's a lot safer on the deck for these guys actually working underneath the cranes. We have this crane in there. He's actually doing lifts for one boat. There's another boat behind the rig now waiting on us. So it's constantly boats coming in and out, and that's part of the job. You always have to look ahead for the next thing that's coming up. It'll keep you busy. It's a busy job.
The dynamic position officer is responsible for the daily maintenance of the draft, trim, and stability of the floating units, for example semi-submersibles and drill ships. Furthermore, the DPO is responsible for keeping the global maritime distress and safety system, updating the radio logbook and testing the GMDSS equipment, as well as assisting the barge engineer and safety officer in the maintenance and updating of the rig's marine and safety equipment as required. Someone can typically start his or her career in the maritime industry, where he or she can obtain the required marine officer certificates, including experience with dynamic positioning. Once he or she has obtained the certificates, he or she can start a career in the offshore industry as dynamic positioning officer. This position comes with an average annual salary of about 85,000 euros.
On this vessel, we have more than 43,000 kilowatts of power. She's got 6 thrusters, 6 engines. We have plenty of power to keep position in case something does happen.
Jessica is in control of powerful thrusters when she is working as a DPO on the bridge on the ultra-deepwater drillship Maersk Viking.
A DPO basically keeps the vessel in position on its dynamic positioning system. We're monitoring that.
The ship isn't allowed to move, even in high seas and strong winds.
Well, the rig needs to stay within, a meter, within a meter of its set point.
The Maersk Viking is currently on contract in the Gulf of Mexico. The drilling can be done at even very deep water depths. Maersk Viking is capable of drilling in 3,600 meters of water, equivalent to 12,000 feet.
Communication is number one on board. We have to make sure that we can maintain position. We have to maintain constant communication with the drillers while they're going down the hole. And we have to maintain constant communication with the engine room to make sure that we have enough power to stay on location while they're drilling.
Maersk Viking is a state-of-the-art drill ship, where safety has the highest priority.
The equipment is state-of-the-art, advanced. It's impeccable.
The subsea supervisor is the head of the subsea section and the overall responsible for the safe testing, installation, and operation of the subsea blowout preventer and control system. The subsea supervisor is additionally responsible for the installation of the marine riser system, including the heave compensating equipment. This position comes with an average salary of about 100,000 euros.
My name is Mick Hall. I'm the subsea supervisor on board the Maersk Viking.
Mick Hall is in charge of anything involved with the subsea department on the new ultra-deepwater drillship Maersk Viking.
At the moment, we are rigging up to run the BOP for the first time.
Mick has the overall responsibility for the safe testing, installation and operation of the subsea blowout preventer, the so-called BOP, and the control system.
The importance of this job is very, very high. The equipment that we work with within Maersk is always at the forefront of technology. Knowing that you're working with one of the best companies in the industry is the main reason.
Offshore installation managers occupy a senior position on an offshore platform, and their annual salary typically ranges between 110,000 euros and 210,000 euros. Offshore installation managers manage all the offshore activities on the platform and ensure that production is performed according to rules and regulations. They are also responsible for the health, safety, and well-being of the workers on board, and are trained to handle emergencies. They oversee the work and training of all the platform personnel, and ensure the timely maintenance and repair of equipment.
My name is Michael Jacobsen. I'm OIM on the Maersk Resolute. I'm 40 years old and I've been with Maersk Drilling for the past 6 years. My responsibility is the safety of the crew and the unit, that everybody gets home in one piece, the way they came out. I care for my job and I also care for my colleagues, and to ensure that we have a good relationship with our client. It's a big part of our life to be out here, and we need to be in a good atmosphere, and it's sort of the second family. When I go to the rig, I have the feeling that I want to go there. I do it because I like it. That's sort of the driver. And we're in a competitive job. We like to drive it to the edge, and that is what's sort of the good challenge for me. The Maersk Resolute is a jack-up. It's purpose-built for drilling new oil wells, new gas wells, and the whole setup, the whole technology is made for drilling and new wells. That's our primary objective, what we're very good at. To give you an idea about the size, the rig itself is 70 by 70 in a triangle. We got 3 legs, each 130 meters long. The elevate weight when we are operating is between 15 and 16,000 tons. The derrick is 60 meter high, and we can drill as far as 8-9 kilometers depending on the conditions. So all in all, a big piece of equipment and toys for big boys. It's always exciting when we do exploration wells to hit the black oil. Even though it's the client's oil, it's always a success for us when we hit bullseye. And that's a good result for the client, because when the client is successful, we are successful as well.
The career mentoring process can be considered as a valuable tool which will assist in discovering the student's potential and aptitude and accordingly suggest the right career path. There are students who are either confused or uncertain about their employment preferences. Moreover, there are students who, despite having a clear idea of what they want to achieve in life, do not know the path they need to follow or the requisite academic qualification. In addition, some students might also have preconceived beliefs about certain professional fields. Hence, career mentoring will also help students overcome these by presenting the true facts. The ultimate objective of the Mentor Project was to develop a framework to provide career guidance and occupational orientation not only to students but also to existing graduates and professionals, and to increase their awareness and properly inform them on job opportunities and relevant prospects in the blue sectors by selecting the proper path. In the context of this e-learning course, the presented framework is adapted to the students. The aim of this framework is to present to the students the opportunities and the required technical skills and behavioral competencies for future employment in the offshore oil and gas industry, and to provide them viable educational options paths. These educational paths are generated based on the identified boundary conditions, and they are the outcome of the mentoring process, which incorporates various guidance layers. The starting point of the career path reflects the current occupational status of the mentoree, and in our case is the student who seeks a future employment in the offshore oil and gas industry. The end point of the career path is the admission of the student to a vocational or academic institution related to an initially selected blue profession of the offshore oil and gas industry. The guidance layers include the awareness familiarization with a selected number of blue professions through speeches, seminars, real-world success stories, and semester projects. The identification of the necessary technical skills that the student should develop in order to achieve his or her admission to the selected vocational or academic institution. The identification of the required behavioral competences that have a direct link with the selected offshore oil and gas occupation. The determination of the available vocational or academic institutions and the respective academic degrees based on the taxonomy by the International Standard Classification of Education. The geographical location of the vocational or academic institutions, and the necessary time for the acquisition of the proposed degrees. This adapted framework for the mentoring of the students generates a series of possible educational threads. In order to select the most optimal one, a constraint regarding the total cost of each thread is introduced. The final selection of the path is based on the cost in monetary values that the family of a student should invest for his/her educational improvement. Finally, a selected code of ethics is implemented during the whole mentoring process and sets the foundational standards. Let's see an indicative implementation of the developed adapted mentoring framework. All available blue sectors: maritime transport, cruise tourism, marine aquaculture and offshore oil and gas are presented to a Greek student, and after discussion with the mentor, the student decides to follow a career path in the offshore oil and gas industry since this sector is more appealing to him. Afterwards, the blue professions that are in most demand nowadays and in 10 years are presented to him/her in order the student to identify the most suitable one based on his/her interests. In this case scenario, the student expresses his/her interest in the blue profession of the dynamic positioning officer. As a result, the values for the boundary conditions are student, starting point of mentoring process, and admission to an education institution for obtaining a degree concerning the blue profession of the dynamic positioning officer, ending point of mentoring process. In this example, in order to hold the position of dynamic positioning officer, someone should have working experience as a master mariner. So, the student should initially acquire the degree of the bridge officer, then gain experience in the maritime industry, and finally switch to the offshore industry and work as a dynamic positioning officer. Having defined the boundary conditions, the modified framework generates a series of educational threads, but for reasons of observance it is decided only a small fraction of them to be illustrated in this presented scenario. 9 educational paths. Initially, the mentor should increase the awareness of the student regarding this blue profession, and a combination of speeches and real-world success stories are organized by the Greek representative of the Blue Career Center, and presented to the student in order to enhance his/her familiarization concerning the content and the requirements of this profession. In case the student is no longer intrigued in following this career path based on these presentations, then he/she can revise his/her initial selection and choose another blue profession. The next step of the mentoring process refers to the identification of the necessary technical skills of the student. The student should have a good knowledge of maths and physics during high school. This knowledge is a prerequisite for his admission in the academic institution for obtaining the degree of the bridge officer. Subsequently, the identification of the required behavioral competencies follows. The student should develop teamwork and problem solving through the assignment of group projects in high school. The next step includes the mapping of the available educational institutions for this profession. The mentoree has expressed his desire to study in his country Greece and not abroad. This initial constraint leads to the recording of 9 available merchant marine academies in Greece for the profession of the bridge officer. Only one merchant academy is located near the residential area of the student, whereas the remaining 8 academies are established in different towns. The time duration for obtaining the degree of bridge officer is the same, 4 years, for all the available academies in Greece. The final selection of the career thread depends on the cost constraint that is inserted in the framework by the applicant. In this scenario, the student decides to follow the most cost-effective educational path. This process leads to the final selection of the mentoring thread, which in this illustrative case is the educational thread 1511. The cost constraint operates as a filter and ensures the optimal selection of an educational path from the student by taking into consideration the economic affordability of his/her family. At this point, the e-learning module for the familiarization of students with the offshore oil and gas industry has come to an end.